You ever sat in your science class and heard your teacher talk about one-dimensional motion? Well, me too, and when I first learned about it, I was so confused. So here I am to give you the short, simple, sweet rundown on one-dimensional motion. Hi, my name is Abby DeLaurie and I am your science instructor for today. Today we are going to be talking about 4 basic parts of 1D motion. These are, what even is one dimension, vectors and scalars, velocity and speed, and frame of reference. First, before we get into anything with 1D motion, we need to know what it is. One dimension is the dimension on the x-axis. This means that there's no up or down. The only movement that can happen is to the left or the right. Now that that's settled, let's move on to the fun part. Now it's time to learn about vectors and scalars. So, the definition of scalar is something that moves with magnitude, or size, to make it simple. I know this doesn't make much sense, so let me draw it out for you. Let's say I had this big box and I push it 10 meters across the floor. The distance I move it is a scalar quantity. Vectors, on the other hand, are very different. Do you guys like how I use the vector? I think it's funny. Vectors have magnitude and direction. Let's say we have the same box, but this time I put it 10 meters to the right. Me saying to the right is really important because I'm giving it direction with the magnitude. And as a reminder, magnitude just means the distance and right is the direction. Our next topic is velocity and speed. Woohoo! So speed is a scalar quantity, while velocity is a vector quantity. Here's an example on how to find speed. Let's say you walk to school, and the school is 100 meters away, and it takes you 20 minutes to walk there. Speed is easy to find if we use this triangle. With this triangle, we can find these 3 things. Distance is speed multiplied by time. Time is distance divided by speed. And the equation we need is speed is distance divided by time. So our distance is 100 meters and our time is 20 minutes. So you're going to do 100 meters divided by 20 minutes. This means that the speed is 5 meters per minute, which just means you walk 5 meters in 1 minute. Now that we understand speed, let's move on to velocity. How we find velocity is by using the equation v equals fx, which is final position, minus xi, which is starting position, all divided by time. Or you can do displacement divided by time. So here's an example problem that all the teen girls are going to love. So you have this hydro flask, right? There it is. And you push it 5 meters to the right, just on this table, right? You have a really long table. It takes you about 2 seconds to do so. How you're going to find velocity is that you know the final position is 5 meters, and you know the starting position is 1 meter, and you know it takes you 2 seconds to do it. So you're going to put it all in the equation like I am doing here. And so you're going to get 4 over 2, because 5 minus 1 is 4. And so it's going to take you 2 meters per second to the right. That is the difference between velocity and speed, is the direction. Our final topic today is frame of reference. Frame of reference is how you view an object moving. So I'm going to draw some examples for you guys so you can kind of see what I'm talking about, and they're going to be really good drawings. So we're going to have 3 examples. One's on the ground, one's in a car, and one's on a plane. I just wanted you guys to see me drawing because I drew really well. If you were on the ground and there was a plane above you moving at 250 meters per second and a car driving past you at 50 meters per second, these things would look like they're moving fast because you are stationary. Now let's say you're in the same scenario, but this time you were in the car. If you looked up at the plane, it would look like it was moving 250 meters per second with an additional 50 meters per second for the car moving the opposite way. And the ground would look like it was moving about 50 meters per second because you feel like you are the stationary thing. Finally, if you were up in the plane, the car would look like it is moving 300 meters per second because it's going in the opposite direction at a speed of 50 meters per second plus the 250 you are going. And the ground would look like it is moving 250 meters per second too, even though the ground's not moving. Frame of reference is really important because it can change your velocity, your displacement, or your acceleration. I hope this video helped you get the basics of one-dimensional motion. If you're still struggling, click the links in my description. They bring you to Khan Academy and they'll give you a more in-depth explanation. Have a good day, guys, and love science!